Oh, this is a this is the block series again. This time what I'll be doing is I've started to I got all my bearings in. There we go. Got all the rod bearings, the crank bearings, and the brush washers. So now I'll be starting the build process after I clean out the block. But the first thing I want to do is I want to measure the diameter of the bearing, the main bearings for now. And I'll do the rod bearings too. But for now, we're going to do the main bearings. So to do this, first off, I have a book in here, uh, New Hemi Engines, How to Rebuild. This is just a book I found that works for me because it has the specifications in here. Where's my bookmark? I'll find the page. So real quick, on page 57 of this book, again, this is New Hemi Engines 2003, How to Rebuild. On page 57, it has the crankshaft specifications. Now, I'm interested in the block the block main bearing diameter. So the length here. So I would suspect that it has similar diameter as the main journal diameter. So this main journal diameter is 2.559 inches. So that's what I use as my metric there. So I'll set this down. And what I do is I have here this sort of like board boy, I'm drawing a blank of what this thing is. Dow bore gauge. There we go. I got this off, I believe, Amazon some time ago. So I just zeroed it out. So what you do is you kind of take this guy, you put it at one end of the journal, and you put the other at the other end like that, and you can see you can measure around to get an idea of what the diameter is. Now, how do you do this? This is a relative measurement. So what does it mean to be relative measurement? So this thing, notice, is reading zero. Okay, zero means something here. This length right here is zero. So I need to figure out what that length is. So what I do is pretty convoluted here, but I have a separate dowel caliper that I use to measure that. So I can sit here, I've already measured it. So I come here and measure it. You can kind of see there about where it is touching. It's not. Uh, so nevertheless, so that's zero. Zero is really, if you look here, zero is really 2.59. So I come back to my book here, put this all down, and you can see that is around where I should be measuring. So 2.559 is the diameter. So let's see what my diameter turns out to be. Now, I'll start taking my measurement. I'll take a few measurements. I'll go across this quite a few times, but what I like to do is where, find where this guy kind of peeks out. You can kind of see. Well, right there. It's 25 mil. Now, so I took a measurement of the diameter of this guy. So, real quick, this right here is measuring 2.559 inches. Let's say 2.589. How I like to do it is, I see I'm right there at number 2, right there where my thumb is at. It hasn't quite hit the 6 yet, so which means it's still on the 5. It's almost right reading time. So that's where that 5 comes in at. And then the last two digits here, the 89, simply comes from this dial. So you can see there, that's 90. This would be 89. So this is 2.89. That's what this is reading. Now, my caliper here, I took a measurement here and I used this indicator to show where it measured. So it measured at about uh that's about 28 mils. So what I do it here is I'm going to subtract out 28 mils, which is 0.028, and that's going to give me 2.561 inches. And now I'm going to come back to my book here and I'm going to see what they say should be the journal diameter. So it says 2.559. So I got 2.561. And so the difference between mine and what they say, 2.559, is 2 mils. Now, I'm going to come hop to the internet because I just went to the internet to check. And on a 5.7 Hemi, it says that the factory bearing clearance tolerance is about that, up to 2 mils for the main journals. So that's what I'm looking at here. These are the main journals. So pretty much, I'm pretty much saying that I believe that I should be fine with the diameter of these main journals for these rough estimates. Um, Next, I'll check the connecting rods. So my numbers pulled up. So 2.561 was the main journal up on the block with the bearing. I'm just going to take a quick measurement of the crankshaft right fast. See real quick. This thing is probably not a great measurement because it doesn't go over the full diameter. As straight as possible. Okay. Alright. Try to measurement. Alright. So looks like I'm measuring about, again, 2, 5, not all the way to the 6. So it's 2.5, 6, about 6.0. So 2.561 is what I was measuring. This is 2.560. So we're talking about a 1 mil difference, and I believe that certainly will suffice um, for clearances. So look, so my measurement on my crank was 2.560. Main journal diameter is showing for the 5.7 was 2.559. So that's 1 mil difference. Which, as we call, which means I'm within spec of the plus or minus 2 mils at most. So that's good to know. So I can also plastic gauge all this just to make sure, but everything's looking good so far with these crude measurements. So just a quick Google search. I mean, it's in my book too, but I do a cross reference to make sure. But for the 5.7 Hemi, should have typed in Gen 3, but nevertheless, the crank to bearing clearance tolerance, however you want to call it, is 1 to 3 mils, which means that when the crank is in here, it can be 1 to 3 mil separation between the crank and the main journal, main bearing rather. Um, so my crude measurements is showing that I'm certainly within that. Um, Again, these are not the cleanest measurements, but these are really crude measurements for to do this really cheap build. Check each cylinder for the diameter. So real quick, I just added a longer extension here to uh, this caliper, measured it out. So you can see here, measured it out, and I'm getting about 3.96. So 3.96 inches is my reference, and now I'm gonna go and check each cylinder from there. Also, what I do is I stick this in here, and I'm gonna go all through the cylinder, take a few measurements. So this right here is a bad cylinder, or at least the one that has the most scarring. But what I'll do is I'll sit here and I'll wait till it hit this little min point right there. I'll set that. Let's see, okay, about a mil off. All right, all right. And then I'll go deeper in, take a bottom measurement. Like it's pretty much the same. I'll go across this way. Kind of see same thing there. All right, and I'll go deeper in. All right, go through all these cylinders, but I'm not gonna bore you all with all, but you can kind of see all about the same. Go a little further down. See it's all hitting about the same. Take this guy, about the same. I'm eyeballing it, but I can tell you right now, I mean, I'm 1 or 2 mils, so in terms of uncertainty, let me eyeballing this. About the same. All right, this side looks good. Alright, again about the same. Go further down. About the same there. I mean, I'll do a cross one just to be, again, not trying to show off too much. Alright, about the same. This guy. Alright, again, we're all looking about 1 or 2 mils within each other. Alright. Okay. Alright, last one here. Alright. Alright. So a reference is 3.9, and then these 2 digits is about 60, round up. Alright. And now we're gonna subtract off this guy, which was about 0.05, a little less than that, 0.049, 3.991. Okay, let's check how that compares to the board. Quick, y'all. So I was getting 3.911, and the board stock is 3.917. So I'm out 6 mils here. And these are crude measurements. I mean, I can if I want to get very close up on these numbers, I can certainly take more legitimate measurement. But for now, I mean, we're talking 6 mils out, which could probably most likely be measurement error. I won't know till I get the piston rings in and actually measure the piston rings and all to make sure everything's fine. But for now, cylinders look good. First journal look good, and I will do the mains next in a later video. But for now, that's pretty much it.